Okay, so this is answer to part C of Wiley homework and also questions for Allison. So, Miss Domzalski, excuse me. So, what we did so far. Okay, so Miss Domzalski, let me ask you this question. Ba, ba, ba. Right, this was so we had a molecule that fragmented right here. It was 2,6-dimethyl 4-heptanol, right? The molecular mass was 144. So it lost, okay, so it fragmented and it became 126, right? So it lost 18 atomic mass units. So obviously it lost oxygen, water. So, okay, the first question, I just want to make sure that right. Right. The book I found on page 434 to how to the mechanism. This hydrogen right here gives one of its electrons up here and gives one of its electrons to this bond right here, and then this carbon to oxygen bond gives both of its electrons, allowing the water to break off, and then this is the molecule that that's resulting, right? I understand that part, but in Wiley we had to write the answer like this. Um, this double bond. How does this double bond form? I don't understand how this double bond forms. So if you could help us with that, and then so this is the answer. This is the C answer, the last answer. I'm going to do the mechanism, and you can tell me if I did it wrong or no. Yeah, I'm going to do a mechanism. I have the answer because I found the answer key. Well, this was the same question that was used in the book. So I knew the answer from the book, but the mechanism about how to get there, if you can help and say if it's right, it would be appreciated. So, right. So here's the molecule we started with, right? So we're looking for the fragment that's 111. And the one we just did was when we lost the water, right? So we lost water. And we came up with this molecule right here. With the radical or the lone electron right there, and the positive charge up here. So from the book, which this was in the book on, I think it was 933. It was question 933. It was the same question as in Wiley. This is the answer that they gave. So this is like kind of how I was able to. This is the answer that they give. So in order to get there, what I did was I took this electron and single barbed arrow moved it there. Single barbed arrow moved it there, but then this doesn't make too much sense. Oh, maybe then this made a single barbed arrow here. Let that go. Now I'm seeing that this is not making much sense because I was saying this had a single barbed arrow go up like this, and this came here like this, and then this came here like this to form this double bond. But now I'm seeing that electrons have to be pushed by something, right? So this is the answer for Wiley, this part of Wiley, and you have to write it just like this with the positive here like this and the double bond like this, otherwise Wiley doesn't accept it. But how that happened, actually, I'm going to see if I can figure that out now, and I'll make maybe a third video on this, and I'll ask Allison if it's correct. But Allison, if you could answer this one, how does this happen? Like, how do you go from this to this? How are these like the same molecule? I know I see there's something that has something to do with the lone electron and the positive charge. This one doesn't have a lone electron or a positive charge. I'm not understanding this concept. If you could elucidate it, I'd really appreciate it. Sorry if this was long. And FYI, once again, this is the answer for MZ111 in Wiley. And I'll eventually post this up. Alright, thanks. Bye.